We are from Team 2, and this is our capstone project, which is Squad Goals. So, what is actually a Squad Goals? Squad Goals is a social habit tracking app where you and your friends can set goals together, upload a photo when you finish them, and your squad can vote to say that whether you actually did it or not. So, the idea is quite simple, which is it is much easier to stick to habits when you and your friends are watching. So, we built and delivered all the 8 MVP features from the spec, and that includes creating account, adding friends and groups, setting goals, uploading a photo, and AI verification step, peer approval notification, and a strict dashboard.
So there are two things that changed from our original proposal, and both were because of real technical constraints that we hit during the development. So the first one is that system-wide scaling policies changed to critical services scaling policies. So instead of applying scaling policies across all services, we focus on scaling only the critical entry point, which is the API gateway, since it handles every inbound request and is the most likely bottleneck under load. So this targeted approach reduces infrastructure complexity while still demonstrating modular independent scaling that can be extended to other services as needed. Second, how we deployed our services. We plan to use ECS Fargate on AWS, which handles containers automatically, but the Learner Lab AWS account don't allow the permission needed for ECS to work. So we switched to EC2 instances running Docker containers instead. The result is still the same. Each service run in its own isolated container. It just took extra work to get there. One thing that didn't change is the mock LLM. The proposal always allowed this, so it wasn't a deviation, and we built it as planned. Also worth mentioning that we also run 5 separate databases, one per service, and this was a deliberate decision to keep services isolated from each other. More on that in the architecture section. Okay guys, so now we will talk about the functional requirements, and I will bring you guys to walk through the app with me.
So I will walk you guys through the demo. So here's the login page. We put in the wrong password. It shows sign in failed. The system is correctly rejecting bad credentials. Now we log in with the right details. We go straight to the dashboard, and you can see the username at the top. And then we create a brand new account after signing up and logging in. The dashboard is completely empty, no goals, no streak, and starting from scratch. For this demo, we have 3 accounts, which is our main user, secondary user, and secondary user 2. We will switch between them to show how the social features work. So the app has 4 sections, which is goals, squads, activity, and profile. In the squad tab, we search for sec. Both secondary user will show up straight away. The social service is searching in real time. We search for fake, nothing comes up. On the real accounts appear. We send friend request to both user. Switching to secondary 1, they accept the friend request. For secondary 2, both now show as friend on the main account, and we can create a group called Iron Squad and invite both of the secondary users. And switching to their apps, we can see the invitations in the notification page, and they will both need to accept it to be in the Iron Squad. And we will see that the Iron Squad is now has 3 members. So next we can create a goal. Create a new goal called Drive Car, and we add a description and select Iron Squad as the group. We can also add multiple goals. We show a second one being added. And yes, this one is the new goal, which is wake up early, and we can put any descriptions that we want, and we can select our group, which is the Iron Squad. And then we can just create a goal, and it will show on our page about the setting a goal. So now the main flow, we log the drive car goal and upload a photo as a proof, and then we watch the LLM indicator. It turns green and says AI verified straight away. Our mock AI service has checked the image and it passes, and we submit it. On the activity page, the goal with no photo shows as pending. The one that we just submitted first shows AI verifying, and then after a few seconds it changes to pending friends approval. That is our system processing it in the background. The AI check happened, it passed, and now it's waiting for the squad to vote. So let's go to the secondary users 1 and then 2, and we can see that the photo, and they will both approve it. So in the notification page, they will approve it, and the notification will go empty again because they already do the approval. So back on the main account, we will see that the streaks is now 1 when both of the secondary 1 and secondary 2 users have approved the pictures, and the group dashboard shows the today's as complete, but because there is one more goal that needs to be completed. It only shows 50% complete. And that is all of our 8 features shown in one go. Also, just letting you know that we also set up and 7 a.m. notification to each of the users. So as it is one of the requirements as well. Now let's talk about the non-functional requirement. So this is our extensibility demo, and the left part is our code that we will be copy and pasting there. And first we start by logging in, and you'll see all the credentials and everything. So to show extensibility, we demonstrate that our services are completely independent from each other by taking one service offline, just like what we would do in the availability demo. But this time the point is different. The point is that nothing else breaks and the other services don't know or care that this one went down, because they can keep on running because they're not connected to each other directly. So we to add a completely new service to the system, you can just create a new folder under services in the in our repository in this same pattern, and then you can just add one line to the API gateway router and subscribe to the relevant SQS channel, and there will be no existing code changes. So this is our K6 log test against the live AWS deployment, and there are 100 virtual users hitting the system over 6.5 minutes. There are 0 errors, as you can see in the screenshots. 11,307 requests has been sent, not a single one failed. All 6 check passed 100%, which is login token, profile, goal, social, and search all responding correctly under lot. The goals endpoint average 240 millisecond fast. The overall P95 came in at 5.66 second. Our threshold was 2 second, so that one got flagged, and that is expected on our EC2 setup because it has no auto scaling. So in production, this is exactly where an ASG kicks in, speeding up more instances as login lot spikes, and the architecture supports it. So next is our availability demo. Now we prove that availability on the live stream. We start with everything running. Login works, account works, social works, goals work. Now we go to the AWS console and stop the social service. We wait for it to show as stop, and we are going to go back to the terminal, and it shows that login still works, account still works, goals still work, but social will return a 502 error, and that is actually expected. That service is done, but everything else is completely fine. Then is service isolation working? One service failing does not take down the whole system. So we then restart the social service. Once it's back up and registered with the load balancer, social will start working again, and all the data is still there. Saving the database friend is still intact. Next, we're gonna do a demo for security on the live system using a curl command. So first, we register a new account. This endpoint is public, no token needed. Then we will then log in and get a JWT token. We decode it and show what is inside the user ID email, when it was issued, when it expires. It's signed by the server. We then make an authenticated request using that token, and it works. It will return our profile, and now we will try with no token. It will return 401 as rejected immediately at a gateway, and we try a fake token, and we will get a 401 again. So finally, we show that the same token works across services. We create a group on the social service and this group all using one JWT. The gateway validates once and all services trust it. So now we will move to our architecture overview. So this is our originally planned architecture, and we are planning on using ECS with auto scaling. It was a solid plan, but we couldn't deploy it because of the Learner Lab restrictions that we mentioned earlier. And we actually ended up having a new system architecture. So this is what we actually built and deployed, where we have 9 independent services running in Docker containers, and then it sit behind an application load balancer. And we have 5 separate PostgreSQL databases. So the 5 databases were a deliberate decisions, yes, because if one of the service gets a problem, then like a bug or a security breach, it cannot reach the other services, and each database only talks to the service it belongs to. So schema changes in one service doesn't affect any others. So why do we choose So why do we choose microservices with a mediator? So we look at three options before deciding. The first one is modular monolith. So one big backend, simple and cheap, but if one part breaks, then everything will break. You also can't scale individual parts, so we ruled it out. Microservices with a broker, services publish events and others listen. Good for loose coupling, but for our verification pipeline, it needs to happen in a specific order where we need AI check, then peer validation, and then completion, and then notification. A broker can't guarantee that order ruled out. And then we have last one, the ones that we choose, which is microservices with a mediator. So the event bus acts as a central controller that sequences the pipeline in order. So that is what we actually built. But the trade-off is the mediator is a single point of failure. But for MVP, that is acceptable. So how it supports a bigger system. Adding a new feature means adding a new services. It plugs into the gateway with one line and subscribers to the event bus. Nothing existing will change. So each service scales down on its own. In production, you would tie auto-scaling to the queue depth and it handles itself. Swapping the mock LLM for a real one is one service change where the interface is already there. There's 5 separate databases mean that you can add a whole new data domain without touching anything that has already been existed. But the main risk going forward is the mediator, which is a single point of failure. In production, you would want a redundancy there. So next we will go to our reflection and lesson learned. So overall, we are really happy with what we have delivered. We met all the 8 project deliverables and we upheld all of our 4 quality attributes, which is extensibility, scalability, availability, and security through the architecture decisions that we made. So what we would do differently next time is that time management and planning upfront. A lot of the pain we experienced came from not researching enough before we started building. If we had spent more time at the start looking at the learner lab environment and its limitations, we would have known that we couldn't use the ECS and passkey from day one. That would have saved us significant rework later in the project. Also, we learned that we need to always be ready for architectural changes. Even when you have a solid plan, constraints come up, such as AWS permissions, environment limitations, time pressure. So the lesson is to expect this and leave room in your timeline to adapt. Our microservices architecture actually help here because changes will contain to one service at a time and not the whole system. Also, define API contracts between services before you start building them because we hit late integration issues because we have team members that made different assumptions about how services would talk to each other. Writing the API specs first would have prevented that. And set up shared infrastructure tools on day one. Our Terraform state backend was added too late, which caused conflict when multiple people were working on the infrastructures at the same time. Paskies were ambitious. We chose them to challenge ourselves, but they introduced an HTTPS dependency, so we couldn't meet in the learner lab. Simple password login would have been the smarter MVP choice, freeing up time for other features. The mock LLM interface should have been built as an adapter from the start, so swapping in a real LLM later would have been a simple drop-in replacement. So next is our lesson learned. What we got right is that the event-driven pipeline was the right call. The async SQS queues mean that user get instant responses and the system stays responsive even under load. So you saw that in both the app demo and the scalability test. Service isolation paid off when things broke during development. Problems stayed in one service, nothing cascaded. And the availability demo showed this on the live stream as well. Terraform from the start gave us reproducible infrastructures. Even with the state backend issue, having IAC meant the whole thing could work from the same setup. The mock LLM was the right trade-off for cost and MVP timeline, and it works exactly as planned. How we would apply these lessons in the future is by researching our environment and its constraints before we design anything. It sounds obvious, but it's easy to skip when you are actually excited to build anything. So next, we will plan for change, which is architecture decisions will shift, build in buffer time, and design your system so changes are isolated. Microservices help us with this. And then write API contracts before writing code, agree on the interface first, and then build independently, and use adapters for any external dependencies so future swaps are trivial. So this whole project, going from requirements to proposed architecture to a fully deployed and working system, has given us a real insight into what a large scale of software development actually looks like, and the technical skills and the non-technical ones. So we are taking all of this forward.